Okay, good afternoon once again. Today we're going to start our introduction to this subject, linear and nonlinear optimization. Now, in other courses, this is called management science or operations research. So I think some of you, a handful of you have had subjects in operations research in your undergrad. So this is more of a review for you. Okay, so linear optimization requires that we create a model with the objective of either maximizing a particular parameter or minimizing it. Okay, so I just gave here a brief introduction to it. So it makes use, of course, it makes use of mathematics and computers. Okay, so we use these tools in order to help management come up with rational decisions, okay, to try to solve or make sense of complex managerial problems. So there are two types of management science. It can be deterministic or stochastic. Our problems will focus more on the deterministic aspect. Okay, let me see. Is there a comment? All right, thank you. Okay, so this is just a diagram of a problem-solving process. I think you're very much aware of this. So you identify and define the problem, you come up with a mathematical model and try to solve that model and assess, evaluate whether the solution is valid. Okay, if not, if yes, then implement. Otherwise, we modify the model. Okay, there are many techniques, there are many processes that are involved in operations research or management science. So some of them are linear programming, weighting, queuing models, dynamic programming. PERT CPM is also part of operations research or management science. And the network models. We also have ILP or mixed linear programming. We have inventory models, analytical hierarchy process. So many modeling tools involved in linear optimization. In our case, we will just be limiting ourselves to some examples of uh, operations, and of course, more on the financial side. Okay, for the first part of our course, we will have examples. Uh, I'll say these will be basic examples, so that I was tempted to come up with more complicated and complex examples, but I said when I looked at the results of the survey, where not so many of you have had the experience of having operations research or having experienced the use of solver, I said that maybe we go to basics first, and then graduate to the more difficult models. So is that okay, class? Is that fine with you?
Yes, sir.
Okay,
Yes,
so
sir.
I didn't want to shock you because you might get mad at me if I give you really more complex, complicated problems. So I know that some of you are either you have echo, and you have had, let's say, many, I think maybe 2 or more subjects in optimization. Okay, so for those of you who have had this, I hope you bear with us as we go through the fundamentals, okay, of this introduction to management science, or otherwise known as linear optimization and nonlinear optimization. Okay, so just in a nutshell, linear programming, as I said a while ago, it's a problem-solving approach. Okay, when you say problem-solving approach, we identify a specific concern or specific issue that management faces. Okay, and then what we do in linear programming is that we have to come up with a mathematical model in order to translate that that problem or that challenge, and then from there we solve it. Okay, before, when I years ago when I had this subject in my college. Okay, we would use a manual method called simplex algorithm, and yung method na yun is so, shall we say, so recursive, no? And it's we can use matrices in solving that. And kasi ang matrix operations sa linear algebra medyo sabihin natin challenging pag kino-compute, no? So today we're blessed, we're happy that we have at our disposal tools that we can use so that it facilitates the problem solving process. Okay, so the objective is either we maximize a certain parameter or we minimize it. Okay, we maximize or we minimize, and then first we're going to learn how to translate the concern, the challenge into a mathematical model, and then after that we will be able to use Excel in order to let's say solve the problem. Okay, so for a linear programming problem, there are three major steps, three main steps. Okay, the three main steps are: we first have to identify the decision variables. When we say decision variables, these are the parameters, these are the quantities that we're trying to solve, that we're trying to determine. It can be, for example, for production, how many units of a particular product should we produce or should we make, okay, or manufacture, so that it will link to the second one, so that a particular parameter is either minimized or maximized. So, for example, we can talk about the production level in manufacturing, and we would like to maximize, for instance, the contribution margin. Okay, so that's an example of a linear programming concern. So we would like to define how many units of let's say product A, product B, product C, product D, depending on the products being produced or manufactured by the company. And then we have a measure for the objective function. It can be to maximize your contribution margin, to maximize your sales, to maximize your profit, or it can be also to minimize. It can be to minimize the total cost, or it can be whatever type of cost. Okay, or it can be minimizing for an HR problem, for a talent management problem, it can be minimizing the total number of staff that we would need in order to let's say, for different time frames, for different time schedules, we'd like to know how many people should be assigned to a particular department or particular task. That can also be a subject of linear programming. Okay, and so many examples, so many applications of linear programming. Okay, when Excel became the vogue, Microsoft came up with this add-in called Solver. So Solver was used extensively in order to solve or to come up with a solution for linear programming. So ando dun yung we will be able to use Solver in order to come up with a solution for a production problem, a scheduling problem, a per CPM problem, an analytical hierarchical process problem, or even a DEA problem. I'm not sure. So let me pose that question to you. Are you familiar with data envelopment analysis? DEA, have you heard of this? Have you heard of this tool, DEA? It's data envelopment analysis. Okay, kindly chat please if you have encountered this tool, this methodology. Okay, no, no. About the others? No. Okay, good, good, because it's an opportunity to learn for us. We're going to have an example of DEA, data development analysis, and it's used for relative ranking. So, for example, you have 20 banks, and you'd like to know which of these banks are efficient. So, data developmental analysis is a very important tool for measuring the efficiency of units. Okay, so what is done here is that you identify inputs and outputs. Okay, and we look at the inputs and output levels of these banks, and then we analyze and identify those banks that are able to utilize their inputs in order to generate more outputs. So that's what DEA does, and that's part of linear programming also. So we will have an example of that also using not only Excel but also using R. Okay, so I just identified some, okay, and some of the possible scenarios that can be solved using linear programming, but not only linear programming, but also nonlinear programming. Linear programming, in a sense, is more limited in that you only deal with linear relationships. Okay, in nonlinear programming, it's you're able to use this because in a greater field, because you're not limited to just linear problems. Okay, for example, when you when you um, when you try to come up with a portfolio in investments, in stock investments, so you'd like to generate a portfolio that will either maximize your returns or minimize your risk. So how in the world will this be solved using linear programming? Cannot be. You cannot use linear programming to come up with a portfolio that optimizes returns, okay, or minimizes risk, because risk, as measured by, let's say, standard deviation or variance, uh, requires a nonlinear modeling. So here is where nonlinear programming comes into play. As I said here, portfolio optimization, okay, and other types of problems where the model cannot just be described by linear relationships among the variables. Okay, so we will have examples of nonlinear problems, but in this subject, the main focus is really linear programming. Okay, now do not expect this to be really complicated subject as far as modeling is concerned. Okay, what's important for us is that at the end of this course, we're able to formulate, given a particular, let's say, a particular scenario, a particular problem, and then we're able to formulate the mathematical model for that and use the tools, whether it's RStudio or Python, in order to generate a solution out of that. Okay. All right. Any questions so far, class? Any questions so far? Are we clear as far as what to expect in this subject? For the linear programming, okay, we will have examples on network models. Maybe we can also touch this PERT CPM. This is for project scheduling, okay, and some other examples. And then, of course, we will have examples in finance, because that's the course of almost all of you. Okay, any questions so far, class? Okay, no questions. Okay, so let's briefly take a look at the steps in linear programming. Okay, I will not really go through each of this line. Suffice it to say that there's a good way in using Excel in modeling. There's a bad way to model, and there's a good way to model. In this subject, we'll try to see what's a good way in order to model a linear programming. So we will of course use also some visuals in formulating our model. Okay. All right. So let me leave it at that first, and then I'll leave you to read the guidelines. Okay, these are just suggested guidelines as far as creating linear linear programming models in Excel. Knowing that, first, when we do this modeling, one of the objective is to communicate whatever whatever output, whatever solution we have. Normally, those who does the modeling do not themselves implement whatever the output is. So this has to be cascaded to another department. This has to be cascaded to other users. So it's important that whenever we design the spreadsheet, it should be, if as much as possible, it should be easily understood, even by those who are not the ones who are creating the model. And of course, reliable, and it should be auditable and modifiable. It's of course it's rank waste if we come up with a model and that we, for example, as particular variable changes, and then we created our model in such a way that we have to look for the values of that variable and change it in several places. Okay, so that's not a good way to create your model. So for me, I'm personally, for example, I'm very particular about giving named ranges. Okay, let me just ask you, class, who among you use named ranges in Excel? Whether it's a single cell or several cells, do you use named ranges in Excel? Anyone? Named ranges. Yeah, kindly chat yes or no so that I at least am informed. Okay, no, thank you. Okay, for tables, okay, no, okay. All right, good. So these are things that we can also insert or include in our discussion in order to, let's say, improve our proficiency as far as Excel is concerned. Okay. All right, and here are some guidelines which I'll just leave you to read because I already want us to start with a simple example of a basic example. Okay, so this is not a rocket science problem. As I said, when I looked at the profile of those who answered the survey, most of you have not used Excel solver. Many of you do not have a subject in linear optimization and or management science. So I thought it best to just start with a very simple problem. Okay, so let's go here. Okay, so this is an example of how linear programming is used in the aspect of operations in a product mix problem. In a product mix problem, we would like to know. Okay, so let me just okay, install my digital pad. Okay, so I'll give you a minute to just go over the problem. Okay, this is a very simple problem, and it's a problem that's encountered mostly in manufacturing companies. Okay, so we have this company and they're producing 3 products. Okay, it's alpha, beta, and gamma. And let's begin with the end in mind. What we would like, what would we like to? Okay, I wonder why is this not? My blank's a border. Okay, never mind. All right. So we have these three products. So let's begin with the end in mind. We would like to here, you need to determine an optimal production plan. So it's a production plan, which means that we'd like to determine how many how many units of this product, alpha, beta, and gamma, are we supposed to produce for the coming week, given these parameters. Okay, so we have these three products, alpha, beta, and gamma, and they need these ingredients in order to be produced. So alpha needs, let's take a look at um, the label here, and this means ounce per pound of the product. This means that we need 4 ounces of chemical A in order to produce alpha, a pound of alpha. So, and etc. No? For chemical A, chemical B, chemical C, and they're using a particular base. Okay, and then we're given some this information that for this coming week, the company has a commitment to produce at least 1,000 pounds of alpha. Okay, and for beta and gamma also. Okay, but there's a disclaimer here. The company management believes that it can sell more of these three products. Okay, so we're told that these are minimum requirements. Okay, minimum requirement for alpha, for beta, and gamma, which means that this will become a constraint. Okay, if you recall, when I show this, these are the 3 steps that we need to identify for a basic linear program. And the third one is to determine the constraints. So this is an example of a constraint where you have your alpha, your beta, and your gamma, and then uh, we're told that the minimum for each should be 1,500 and 400 respectively. Okay. All right. Then we're also told that they make use of these ingredients, and then current inventories. Okay, so we have inventory levels of the ingredients. So for chemical A, there are only 500 pounds left in inventory for chemical B and for chemical C, and then also for the base. Okay, so we have data about the inventory level of the ingredients that's used in order to produce these 3 products. Okay, then we have here another information that every pound of alpha, okay, nets the company a profit of 350, while for beta it's 340 and gamma for 300. Okay, so we will wear the hat here of the operations manager. So we will need to come up with an optimal production plan for the week. Okay, when we say optimal, we mean that it satisfies a particular objective. And that objective can be to maximize something or to minimize something. All right, so let's start first. Okay, so the first step is let's identify the decision variables. Let me copy this because this is what we need in order to craft our model. All right. Okay, first is identify the decision variables. The decision variables are those variables or those parameters that we need to decide on. Okay, to decide on. Okay, what do you think for this problem are decision variables? The root word itself, decision, decide on. already gives us a clue. What are we to decide on? So knowing that, what will be our decision variables? Okay. Yeah, thank you. Thank you. Erwin, you're correct. It's the number of products to produce. Correct. So we have 3 products, alpha, beta, and gamma. So we would like to know how many of each, how many, this is weight, no? How much of each we should be producing for the week. Okay, so let me write that. So number 1, let me just use we have our decision variables. And our decision variables is, what are they? So we have your alpha. So let's let the variable be equal to alpha. And a good model will define what your alpha is. So what do you think? How should we define our alpha? How do you think should we define our alpha? Anyone? Anyone? Can anyone suggest? Because we have to define our parameters. The alpha is what? Alpha is, yes, we're going to use the variable alpha, and we'll also use beta and also gamma. But how do we define them? Anyone, please? Is my screen size okay? Can you see? Class, can you see? Hello.
Yes, sir.
Yeah, may I request, class, that if I have queries like this, paki-respond naman kasi we will be wasting time if you don't respond, no? Okay, thank you. Thank you so much. Simple queries like that, no? I expect an answer from you guys. Okay, so thank you for answering. All right, so how do we define alpha? We have to define it contextually, okay? So what's alpha? It's not to say alpha is, we're not going to say alpha is the spongy product of king foam. It's not that. Alpha, being the decision variable, has to be defined contextually. Okay, so if you take a look at this, diba, this case calls for us as operations manager to determine the production plan for the week. Okay, so alpha should be the number of what? What's the dimension of alpha? Okay, we're given the dimension, the pound of the product. Number of pounds to produce, right?
Volume, sir.
Yeah, okay. The volume at pounds is weight. So, hindi siya volume, no? Weight siya. Okay.
Sorry, yeah.
Yeah, it's okay. Okay. Number of pounds to produce or weight to produce for the week. Well, I'm just going to, just to give you an idea, no? For the coming week. So this is just one of the ways in order to define what your decision variable is. In this case, alpha. The objective is communication, okay, and reproducibility, so that anyone reading this model, looking at this model, can understand what you're solving for. Okay, so beta will be, of course, let me just use this number of pounds to produce for the week. Number of pounds, maybe I should insert here. Number of pounds of alpha to produce for the week number of pounds of beta and number of pounds of gamma, right? To produce for the week. And I'm not going to write everything there. I'm sure you understand. Okay, so let me pause for a while. Is this clear? Of course, class, your case studies will not be as easy as this. No? So we're just starting with basic ones. Okay, you might be saying that, is this master's level? Well, not yet necessarily, but we'll get there. Okay. Okay. Feedback, please. So far, clear. Any questions? Any clarifications?
Clear, sir.
Okay,
Yes,
thank
sir.
you. Thank you.
Clear,
You may chat or you may unmute yourself. I'll appreciate that. Okay, so good. Then what's the next one? The second one is our second problem is not problem, but step, which is to identify the objective function. Okay, so objective function, therefore, okay, there are two types of objectives. It's either maximization or minimization. So either we maximize something or we minimize something. Okay, in the context of this problem, in the context of what's given, okay, what do you think should be our objective? And if so, what should we be maximizing or minimizing?
Maximizing production po for this week, for a week.
Okay, so maximize production. Okay, any other? Okay, sorry, I failed to. Chari, ikaw ba yun? Was that you?
Yes po.
Okay, thank you, Chari. Okay, but let's see if is it maybe there are other information here which should Erwin, no, sabi ni Erwin, maximizing profit. Okay, so why Erwin? Why is it maximizing profit?
Because sir, it's the objective of the business is to make money for the company. So
Okay.
we need
Okay.
to maximize profit for the shareholders as well.
Okay, that's right. That's right. But contextually, could we compute for that? If we say maximize profit, could we compute for the profit given the information that we have?
Yes, sir, because it's given here that, for example, each pound of alpha nets the company a profit of 350 and
Okay.
so on.
All right. So, okay, that's good. Thank you. So each pound of alpha, so we're told that each pound of alpha nets the company a profit of 350. Okay, a profit of 350. So we can say that the objective here, okay, profit of 350. Now, what by the way, what's the profit here? What do you think is the profit here? Because especially in accounting, medyo maraming can have different meanings for profit. What do you think is the meaning of profit here?
Sir, selling price less cost to produce the product.
Okay. All right. So it's selling price less less the cost to produce the product. Okay, and also other indirect costs, most probably. Pero it will be more on the variable cost, no? Kasi meron tayo ditong nets. No? Nets, ano yan? Nets the company. So most probably we can assume that this is your contribution margin. Okay? So contribution margin, from what you have learned in your accounting, that's your selling price per unit minus your variable cost per unit. Okay? All right, so here we can say that the objective is to maximize, okay, maximize our profit, aka your contribution margin. Okay, so that's our objective. But how can we measure the profit How can we measure the profit? We have to come up with a function for that. We have to come up with a measure for that. So what do you think should be the profit? Okay, so let's identify, or the contribution margin. Let's use a variable, let's say Z, okay, max Z to be equal to. So I'm putting here max, which indicates that this is a maximization problem. Maximize Z is equal to, so what's our equation for our total contribution margin? Okay, anyone?
Sir, the number of alpha times 350. And
Okay.
then plus the number of beta times 340.
Okay,
And the number of gamma times 300.
okay, good. So let's call that contribution margin or profit margin. So contribution margin of alpha multiplied by, right? Since we defined the number of units to be alpha, multiplied by alpha, right? And then plus, okay, I hope you understand my handwriting. Okay, so that's the contribution margin of alpha multiplied by alpha, which refers to the units of alpha to be produced. Then the contribution margin of beta multiplied by the multiplied by beta, which refers to the number of units to be sold, and contribution margin of gamma multiplied by the number of units of gamma. Okay, so the summation of this will give us the, okay, let's define this to be your, okay, here, this will be our total contribution margin. Okay. So let me pause for a while, allow you to, if you're copying, or allow you to let this equation sink in, because I know that there are some of you, many of you who are not business students, you did not take business, you were not in the business field, so we'll have to go through this deliberately. Okay, so once again, the objective function is to maximize our contribution margin or our net profit, and we use a function to do that, to explain that or to compute that. So we have the contribution margin of alpha times alpha plus the contribution margin of beta times beta plus the contribution margin of gamma times gamma. Okay, clear so far, class? Any questions? Any clarifications? Feel free to ask your question. Okay, anyone? All right, so no questions. Okay,
Answer.
yes?
No
Okay.
questions, sir.
Okay, thank you, thank you. All right, I think I should have placed the question in a positive light. Huh? I should have asked, is it clear? Okay, so, and then I would ask you to key in yes or no. Huh? Okay, so third, what's the third step? And that's to determine the constraints, identify the constraints. So that's number 3. Step number 3 is for us to identify or define the constraints. Okay, so for the constraints, I mentioned a while ago, we know that in any company, there will be certain limitations, certain constraints. You have resource constraints in the form of materials, in the form of inventories, in the form of time, okay, in the form of manpower. There are many constraints as far as a company is concerned. In fact, if there were no constraints, then we can just say produce billions of pounds of alpha, billions of pounds of beta, billions of pounds of gamma. Because in that case, if we do that, then we will have billions of contribution margin, because the summation of that will of course run into billions. But can we do that? is it possible to produce billions of alpha, billions of beta, trillions of gamma? What do you think, class?
No, sir.
No, sir.
Why not?
Because there's
Cost.
a
Limited
because of the
resources.
inventory.
Ayun, correct. That's it, no? That's it. There are limitations, and limitations are also called constraints. So in coming up with a model to determine the production mix units, okay, we have to be guided. We have to be guided by the fact that there are certain limitations that the company faces. What's the company? What's the name of the company? That this company faces, and the solution to your to this linear programming will also be based not only on the fact that we would want to maximize profit, but it will be based on certain limitations that the company faces. Okay, in fact, you were telling me that the inventories of the raw materials, Chem A, Chem B, Chem C, and the base are limited. So Chem A has only 425 pounds. 500 pounds of Chem A. So how can we produce billions of pounds of alpha if we have limitations as far as the raw materials is concerned? So we have to define this, and we have to input this when we use Excel to solve this. Okay, we're not going to use simplex algorithm to solve this because it will take us several sessions to solve one problem. So I don't want you to experience what I experienced before, when solving just one problem will take us days. Okay, it's prone to a lot of errors. Okay, so let's define our constraints. Can anyone please give me one constraint? What's one constraint?
Cost, sir.
Cost? Okay. Where's the cost? What cost do we have here? Are we given something about the cost? Do we have information about costs that
The current inventories.
inventories? Okay, inventories of the ingredients.
The ingredients.
Are you referring to that?
Yes,
Oh,
sir.
sorry. Okay, Shelley, thank you. So can you define one constraint in the form of an equation, Shelley? Because the constraints, okay, should not only be known qualitatively or theoretically, it has to be translated into an equation. So anyone, please? So Shelley mentioned that one constraint is the ingredients. So let's identify one ingredient. What's one ingredient?
Chem A.
Chem A, okay. What's the constraint as far as Chem A is concerned? What's that, Rosel?
Yes, sir.
Nahuli ko yung pangalan mo. Tinago mo kagad.
Wala pa akong pinaga, sir.
Hindi, joke lang. Sige, Rosel. Chem A. What's the constraint about Chem A?
The constraint, to make all the products you need, wait lang, 13 for Chem A, but there's only, you need 13 units or pounds of Chem A to make for the alpha, beta, gamma. So,
Okay. All right. So you need 13 ounces, hindi pounds.
sorry,
yung ingredients
ounces.
natin. Oh, it's okay. It's okay. So for every, now iba-iba sila, no? So we say that alpha needs, for every pound of alpha, we need 4 ounces of Chem A. Okay, etc. Okay, so can we write that as an equation?
Sir,
Yes.
is the constraint related to the commitment?
Commitment, that can be a constraint, no? Kasi,
Commitment to produce since you're limited with inventory.
yeah. Okay, we'll tackle that, no? Thank you, Rex. We'll first look at the Rosel and Shelley's answer. Sabi nila, may constraint tayo as far as the inventory of the raw material is concerned. So But thank you for mentioning that kasi we'll go, I'll call you next. Sino yun? Si Rex ba yun?
Yes, sir.
Rex, I'll call you next to expound on that. But first, let's go to what was mentioned by Rosel and sino ba yun? Nakalimutan ko kagad yung isa, no? Shelly ba yun? Okay, so how do we frame mathematically the constraint for chemical A? Because you're correct. We have resource constraints, resource limitations. Hindi bottomless yung ano yung Chem A, yung Chem B, yung Chem C. Okay, so we need to craft an equation that demonstrates or that shows us that computes for the usage of Chem A. Okay, so anyone please? What will be our constraint for Chem A? Any volunteer?
Sir,
Yes, Erwin?
the total chemical A should be less than the number of alpha times the needed chemical A to produce alpha,
Okay,
plus the number of beta times the needed amount of chemical A to produce beta, and then plus the number of gamma times the number of chemical A needed to produce gamma.
okay, thank you. That's correct. But Erwin, let's just translate that to numbers na, no? Sige. How should we put it? So that's correct. Sino ba to? Bigla akong nakalimutan. Sino yun? Who was the one speaking?
Erwin, sir.
Erwin. Sorry guys. Minsan nasa RAM yung ano yung pangalan. So bigla nawawala yung sa memory ko. Nasa RAM kasi. So, dapat ilagay ko na sa ROM, no? Okay, so Erwin is correct. Sabi niya, we multiply, okay? We multiply the use. Okay, for alpha, we need 4 ounces for each pound of alpha. Okay, so 4 times what? So our equation for our constraints will look like, how will it look like, class? So let me just use 4. Okay, but when we go to R, we don't encourage to write this. We would encourage us to write this as a variable. Okay. So this is the number of ounces that we need in order to produce a pound of alpha. So how much do we need? Class, how should our equation look like? We would like to continue this. It's 4 times.
4 times alpha, sir.
Okay, correct. 4 times alpha, diba? Kasi alpha, we defined alpha to be the number of pounds to produce for the coming week. All right, then we have plus
3 times beta.
3 times beta, okay?
Yes, sir. And plus 6 times gamma.
6 times gamma.
Yes, sir. Less
Okay.
than 500.
Okay. All right, it should be less than 500. Is it possible for the Chem A to be fully utilized? Erwin?
Yes, sir, it's possible. So less than or equal 500.
Yes, okay, thank you. So the relationship between the usage of your Chem A should be less than or equal to what? What's this?
500. Sir.
500. Okay, 500. Okay, so this is your Chem A. Okay. Let me just use Chem A inventory or just Chem A.
4. Okay, 2, 2, 3.
Chem A inventory. Okay, again, we have to define the constraints. You know why? Because as I said a while ago, chances are you're not the only one who's going to make use of this model. So others who would review this or who would like to see how you formulated your linear program has to know how you formulated your constraints, your decision variables, and your objective function. Okay. So that's the inventory constraint for your Chem A. Okay, how about for Chem B and Chem C? I think since you already have seen the first one, so let me just use here 2 alpha plus 2 beta plus 3 gamma should be less than or equal to how many? So 500 and 425. Okay, and then we have for Chem C 425. We have 4 times alpha plus 2 times beta plus 5 times gamma less than or equal to 650. And finally, we have the fourth material, which is a base used in the manufacture of this foam. What's that? 692. So it's 6 times alpha plus 9 times beta plus 2 times gamma is less than or equal to 1100. And then we define this to be your base inventory. Okay, let me pause for a while and ask you.
Kasama ko na uminom.
Okay, let me pause for a while and ask you to please chat if
Nahihilo pa daw.
we're okay so far.
Teka lang. Sabi ko, nag-aaral. Ito. Ito notes ko. Gusto mo? Nahihilo.
Rosel, okay, mute muna.
Sorry po.
Oo. Okay, thank you. Okay, so, yan. Paki-chat nga, class, kung yes or no, kung, I will not write here anymore Chem B, Chem C, and base, no? Sige na nga, isulat ko na. Because I might send this file to you also in case you need it. So this is Chem B inventory, okay, Chem C inventory, and the base inventory. Okay. All right. Okay. Clear so far, class, yung first four constraints na. May I have your, yeah, thank you. Your feedback, please.
Clear.
Okay, thank you. All right. Then, are there any other constraints? So let me go back to si Rex, no? Rex, a while ago, you were mentioning something about the order. Okay. So
Yes, sir.
What about the order?
Since Alpha provides the most profit to the business, ideally it's the one that have to produce more. Although there's a constraint that company has committed to produce certain number of alpha, beta, and gamma. Thus, we cannot allot all chemical and base to alpha and have to allot to accordingly.
Yes, correct. So how do we now translate that into a mathematical equation? Because in order to solve this, we have to identify all of the constraints and translate them into a mathematical equation so that we can load this to Excel, particular solver, and ask X solver to solve, to determine matrix JSON, okay, equation lang, no? Just an equation that will capture yung what Rex mentioned a while ago, that we need to consider the limitation as far as the the production is concerned. Okay, how do we now translate that into an equation? Is there a constraint as far as how much alpha to produce?
Yes, sir.
Okay.
Alpha should be greater than or equal to 1,000 pounds.
Okay, so I write alpha here, alpha should be greater than or
Greater than
equal
or
to
equal to 1,000.
1,000. Okay, all right. So okay, maybe we can define this to be, so it's always good practice to give a definition. Minimum demand alpha. Okay, so that's the minimum demand for alpha. So do you agree with this equation, class? That alpha should be greater than or equal to 1,000.
Yes, sir.
Okay,
Yes,
correct.
sir.
Now, take note that any constraint can either be greater than or equal to, or less than or equal to, or equal to. There is no constraint that's only greater than or less. Okay, if we do this, it will leave the solution unbounded. Okay, so there will be an infeasible solution for this if we have less than, greater than, or only less than. All constraints are always greater than or equal to, less than or equal to, and equal to. Okay, so I think I saw a chat here. Okay, thank you. Thank you, Robbie. All right, so this is correct. Thank you so much, Rex. Rex pointed out that there's a constraint as far as the level of production for alpha. Okay, the company has committed to produce at least 1,000, and there's a statement there also that says that that they foresee, okay, it can sell more of this, each of these three products. Okay, next. So of course, what will be our minimum demand for beta? What's our minimum demand for beta? Greater than or
500,
equal
sir.
to?
100.
Okay, 500. Thank you. And gamma is
400.
400. Okay. All right. So are there any other constraints that we need to include in our model? Do we have other constraints? Okay, 400. Okay, thank you, Robbie, for the gamma. So are there any other constraints? So far, we have defined the constraint for the inventory of the raw materials, of the ingredients. And then we also have defined the constraint as far as the production unit is concerned. Okay, are there any other constraint? So this, we have here resource constraints, demand, market demand constraints. Okay, any other constraint?
Sir, the number of products should be an integer, meaning should be a whole number.
Ah, okay, wow, interesting. Who said that?
Erwin, sir.
Erwin, okay, Erwin. Okay, let's thank you, Erwin, for that. No? Okay, let's analyze that. Ang sabi ni Erwin, Erwin said that the units of alpha, beta, and gamma should be integers. Okay, what made you say that, Erwin?
Because we cannot partially produce a product, because if it's only a partial product, it's not going to be useful.
Okay.
So it must be a whole.
All right, that's good. That's a very good observation. However, no. However, the units are the product are in weights, no, pounds sila. Okay, so maybe unless there is a statement that says that the item should be produced in integral units, okay, then we will impose that constraint. However, there is no statement here that tells us that the units to be produced should be integers, should be whole numbers. If this was discrete objects, like for example chairs, tables, TVs, computers, then definitely we have to impose that the unit should be integers. Okay? However, ito kasi ano siya, hindi naman siya mga discrete objects, no? Alpha, beta, and gamma are products that are measured in terms of weight. Okay? So perhaps at this point, maybe we need not include that constraint. Okay? What do you think, Erwin? Does that
I
sound
agree, sir.
reasonable?
Yes.
Okay. But thank you for pointing that out. No? That's very good, because in the next problems we will have decision variables that will require for us to put, okay, to impose that the solution set should be an integer. Okay, thank you, Erwin, for that. All right, so in this case we said that maybe no need this time, because the product, the dimensions of the product are in weight, no? Pounds kasi siya, no? So no need to be really very exact with the, unless sinabi sa problem na kailangan we need to measure the products in exactly in pounds or exactly in as whole numbers. Okay, let me tell you one constraint, but one constraint that's not needed. One constraint, as I said, that's not needed. However, but almost always it becomes it's a part of how should I put it? Okay, isulat ko na muna, no? Okay, I have a chat here. Okay, how about time? Is that a valid constraint? Okay, Robbie, thank you. Pero anong natin? How do we include time here?
Baka hindi na pala, sir, kasi ano naman siya across parang for this context nata hindi pala applicable.
Yeah, okay. But you do make a good valid point, no? Okay, I'll get back to the answer of Erwin, no? Okay, so dito, sabi ni Robbie, how about time? Now, time can be a resource constraint, no? For example, if we were given that for every day the company only has worked for 8 hours, tapos given tayo ng time to produce alpha, beta, and gamma, then pwede nating isama yon, yung constraint na yun, na time constraint. Okay, however, in this problem, we were not given, kaya nga sabi ko medyo simple lang tong problem na to. Yung mga susunod na problems natin in the next weeks, yun, mas complicated na talaga yun, no? For this one, I just want us to have a feel of how to formulate a linear problem, and then go through the process, okay, and then solve the problem and come up with a solution. Okay, Erwin mentioned that non-negative. Okay, so that was what I was pointing out. No? So non-negativity is also a very important constraint. So let's put here alpha, beta, and gamma. We can put them all together as one because they have the same constraint, greater than or equal to 0. Okay, and if there's a need to make them integers, lalagay natin greater than or equal to 0 and integer. Okay. Now, if there's no need to make to put this constraint of integral solutions, don't put it. Okay, don't put a constraint for the solution to be an integer, because this makes the model more difficult. Integral integer linear programming is more difficult than the ordinary linear programming. So as much as possible, if hindi naman kailangan na integer yung solution, do not include that integer. Okay, thank you, Erwin, for including this. Okay, however, so just be cognizant, class, that if there's a need to put this, you have to put this, because you cannot produce a negative amount of alpha. You cannot say that negative 10 pounds. Okay, is it possible for that to happen? Yes, it's possible for that to happen. You can have negative solutions. If you fail to impose this positivity constraint, then it's possible that Excel will generate a solution where one of your decision variable is a negative, okay, which in this case cannot be, because we're talking of products, we're talking of weights, and there can be no negative weight. However, in this case, this is what we call a redundant constraint. Redundant constraint. Now, why is this so? Why is this called a redundant constraint?
Because sir, we already set a minimum amount for the products, the 1,500
Okay.
and the 400.
Yes, correct. Thank you, Erwin. So you answered you gave a comment to your answer. That's very good. So this is redundant. We don't need this to impose that alpha, beta, and gamma to be positive. Okay, why? Because you have already floor values here. Minimum value of alpha is 1,000, beta is 500, and gamma is 400. So if we're going to impose this constraint, it's not possible, it will never be possible for alpha, beta, and gamma to become negative. This takes the place of the non-negativity constraint. Okay, so let me pause for a while and let me ask you to chat if so far what we have discussed is clear. Let me first review what we have done. So first, we define the decision variables. Our problem calls for us coming up with a optimal production mix. So we need to define how many pounds of alpha, how many pounds of beta, how many pounds of gamma to produce for the coming week. Then, based on what was given in the problem, we formulated our objective function. And we said the objective function will either be a maximization problem or a minimization problem. In this case, what's given is the contribution margin, or net profit. So we would like to maximize that. And we said that we need to set up that equation. So we're writing here max z is equal to the contribution margin of alpha. Okay, by the way, I'm using here CM alpha. Okay, that means that we have to define this before we use this variable. Okay, we have to define what CM alpha. Okay, we already defined alpha here, so we have to define what CM alpha, contribution margin of alpha, etc. Okay, plus contribution of margin of beta times the beta to produce, and contribution of gamma times the gamma to produce. So that the summation of that, the sum of that will give us the total contribution margin. And that's what we want to maximize. Okay. In other problems, what might be given is just the cost. So we would want to minimize the cost. Or if we're staffing and the company would want to utilize optimally the distribution of the workforce, then that can be a minimization problem. All right, so maximize z to be this function. Okay, and then finally we have the constraints. So we have here resource constraints. Our chemical A has only 500. Okay, chemical B 425, chemical C 650. Okay, and then also the base, by the way, 1100. And then also constraint with respect to the market demand. Okay, the minimum demand for alpha, beta, and gamma, which we identified here. And then we said that it's good practice to always consider putting this in, the non-negativity constraint. However, we said that this one, in this case, becomes redundant. It's no longer necessary because we have constraints that are part of the model that will definitely impose a non-negative solution to our model. All right. Okay. Clear so far? Again, pardon me for asking this question always. Okay,
Clear,
good.
sir.
Thank you. Thank you. So the others, please either chat or unmute yourself. Okay. And please do not be ashamed to ask questions. That's what I like with master students. No? They're not ashamed to ask questions. Okay, and there may be some instances when your question can be quite challenging and I might not know it. So we will try. I'll be honest. If I don't know the answer, I'll tell you. Okay, we'll research about it. But that should not detract you or prevent you from asking questions. Okay, very good. Thank you so much. All right, one last look. Okay, one last look before we solve this simple example of a linear programming. All right, that factor which I want you to look at is what we call dimensional consistency. Now this is very important because some would make mistakes in coming up with a solution because there's no dimensional consistency. If we take a look at the constraint class, there are two parts there. This one, the one to the left of the operator is called your left-hand side, LHS. And the one to the right of the operator is your RHS, right-hand side. Okay? So in any constraint, make sure that there is dimensional consistency. What do I mean by that? If the left-hand side is in meters, then the right-hand side should also be in meters. Okay. Otherwise, of course, you know that if there's inconsistency there, then the model is wrong. Okay. We will have a wrong model and a wrong solution. Okay. Let me give you a minute to check if there's dimensional consistency. Always do that, class. Dimensional consistency. If it's okay, then please chat yes. If you think there's a problem, then voice it out.
Sir, I think it's for the ingredient constraint because given in the table it says that it's ounce per pound, and then for the right hand side you just need the pounds.
Okay, so Jovil, what's the left-hand side for the ingredients? For example, the first equation here. What's the
The left
dimension of
hand
this?
side is the ounce, sir,
Okay, and then the right-hand side is?
is pound.
Okay, there you go. Exactly. Thank you, Jovil, for that. Correct. That's correct. So as I said, do not just stop at looking at the formulating the model. You have to check for dimensional consistency because that can happen. Make sure that the left-hand side dimension is the same as the right-hand side dimension. So Jovil is correct because the table that's given, the values of given in the table is the ingredients are in ounces. So this is 4 ounces. 4 ounces per pound of alpha. Okay, so the equation that we set up here, Jovil is correct, is that 4 times alpha, this is 4 ounce per, okay, let's just write that. Okay, so for example, if we're going to produce 100 pounds of alpha, so 4 ounces per pound of alpha times 100 pounds. of alpha because alpha is in pounds, right? So the pounds will cancel out and we have ounces here. So the dimension of the left-hand side are all in ounces. Okay. And this 500 is in pounds. Okay. So that will give us a wrong solution. Okay. So how do we make sure that we have dimensional consistency? Okay. We
But-
either yes. Sorry. Yes. Who was that? Was somebody trying to answer?
Sir, we have to convert the ounce first to pounds.
Okay. The ounce to pounds, or it can be
Or the pounds to ounce.
Ounce to ounce.
Okay, so it's really a choice, no? And when you choose, of course, choose wisely. So which do you think is better, to convert the ounce to pounds or the pounds to ounce in this case?
Ounce to pounds, sir, because the rest of the given data is in pounds.
Okay, can be ounce to pounds. So if we do that, so we're going to convert each of these into pounds, right? Tama ba?
Yes, sir.
Okay, this will be converted into pounds, into pounds, into pounds. Okay. Any other suggestion? What do you think? Are you okay to that?
Pwede po bang i-multiply na lang yung 500 sa 16? Kasi
Pwede rin
1
yun.
pound is 16 ounce.
Yeah. Oh, sino? Chari ba? Ikaw yan?
Yes po.
Yeah, Chari, pwede rin yun. So, spoken like an engineer, no?
Yeah, because I don't want to edit a lot of things.
Correct. Pwede rin yun, no? Jovel, tama din naman sinasabi ni Jovel, no? We can convert everything to pounds kasi nga, for consistency. Para lahat pounds. Pero, yung metric kasi ng raw material natin, no? Yung chems, they might be naturally in ounces, kaya mga ounces yung linalagay din sa table. So, and an easier way to convert will be yung singular number doon na 500, di ba? So we can maintain the ounces metric, and then just convert the 500 pounds into ounces. Okay, all right. But whatever way you do, you get still the same answer, the correct answer. Okay, my point here is that make sure that you do dimensional consistency, to check for dimensional consistency. Okay, so in this case, for the interest of time, let's just convert the pounds into ounces, and Shari is correct. The conversion of 1 pound to 1 pound is 16 ounces. Okay, so how much would be 500 class? Kindly, please. What's 500?
8,000, sir.
Okay, so this is 8,000. I'll just put here 8,000, no? So that you'll recall. Okay, 425 is
6,800.
6,800. And then this one is,
10,400.
thank you, 10,400. And then this one,
17,600.
17,000, what?
600.
600. And then this one,
Which one, sir?
this one. Ang galing, ayaw sumagot. Kasi hindi naman natin i-convert yan, di ba?
Again, yes.
Right? Oh. Thank you. Who was that who answered? Sorry, hindi ko nakita kung sino yung sumasagot.
It's Erwin, sir.
Erwin, thank you. Yes. Alam ni Erwin na I was joking with him. Kasi when I asked this, he did not answer. He stopped. Most probably he recognized that I was kidding him or joking with him. So this is not to be converted, because alpha is in pounds and this is in pounds. So no problem with this. No dimensional inconsistency. Okay. All right. So far, how are we? Okay. Comment please. Pa-chat naman if the pace is slow. Okay, kasi I might be accused of being too slow. Okay, thank you, Robbie. Pace is just right. How about the others? Kamusta naman? Kasi I can of course accelerate a bit, no? Just right. Okay, thank you. Good. Thank you. Thank you. And as we get the hang of this, of course, we will move a bit faster, no? Kasi alam na natin. Ngayon kasi first na problem natin to. No? Okay, quick review, 3 steps. First, the decision variables. Be sure to define them properly. Okay. Second, objective function, either maximize or minimize. Okay, and define the function. What are we maximizing? What are we minimizing, if ever? And then the constraints. Okay, set up the equation. The constraint can either be greater than or equal to, less than or equal to, but it can never be greater than or less than. Okay, there's this left-hand side, there's this right-hand side. You have to define what they are. Okay, again, what's this for? For communication purposes and for reproducibility purposes. Okay, and then try to see if there's a need to include the non-negativity. You call this the non-negativity constraint. Okay, and of course, double check for, as I said, dimensional consistency. The left-hand side should always have the same dimension as the right-hand side. Okay, so that in a nutshell are the 3 steps that we need in order to set up our linear model. Okay, I noticed that we have gone overstepped that into more than 2 hours na tayo. So is it okay with you if we have a quick water break? Okay lang ba sa inyo na mag-water break muna tayo for maybe 10 minutes, 3:40, and then we come back at 3:50? Is that fine with you, class? Okay, kasi baka masyado ng mahirap din yung masyadong overloaded na kagad at saka iba sa inyo nag-notes pa. All right, it's by my watch here, it's 3:40. So let's come back at 3:50. Okay? So sige, water break muna tayo. Okay, let's continue with our discussion. Okay, are you all set, class?
Yes, sir.
Okay, all right. So let's what we have done so far, given this product mix problem for this company King Foam, we defined the decision variables, we defined the objective function, and we set up the constraints. So the next thing for us to do is now to solve this problem. And we're going to use Excel as a platform for this problem. So why don't we just add a new worksheet here. Okay, I just added a new worksheet here. And then maybe let's copy this given. Okay, let's just copy this as a reference. I just put it somewhere here. Okay. So first, our decision variables. Okay. It's always good, plus, to have a model where the absolutes are separated. Okay, I'll as we go along, I'll discuss that with you. Okay, so first, let's identify the decision variables. We have your alpha, your beta, and your gamma, right? Each decision variable should be represented by one cell. Okay, so maybe I'll put here first let me name this as alpha. This is our beta. And this is our gamma. And we will have to, assign a particular cell for alpha, beta, and gamma. And then it might be good to, it might be good to do color code in a cell so that you can easily know if that's the decision variable or the or the objective function, or the constraint. Okay, so I'll color this just light blue, and maybe make the font. Okay, anyway, I think that will suffice for now. Okay, there are different ways to solve this in Excel. But what's important is that we set a cell for each of the decision variables. So this is your number of pounds, right? This is number of pounds. Number of pounds for the product, right? Alpha, beta, and gamma. Okay. Next, we have to come up with we have to set one cell for the objective function. Okay, the objective function, we go back here. This is the objective function, right? Contribution margin of alpha times alpha, contribution of margin of beta times beta, etc. Okay, so okay, let me. Okay, sometimes the givens, it's best to have a cell that's allocated for them. So let me write here CM CM what happened to my saan yung ano ko? Formula bar. Why is my formula bar gone? Strange. Where is my formula bar? I can't find my formula bar. This is weird. Okay, anyway, what's this? Ribbon display options. Ang daming bago ng 365, no? Auto hide ribbon, you don't want that. Show tabs. Show ribbon tabs only. Show tabs and commands. Okay, it's not that, no? Okay, anyway, I can't find my formula bar. All right, so CM. So we either type alpha, CM alpha, CM underscore beta, and then CM underscore gamma. What's the CM for alpha?
$350, sir.
350, 350, okay? And then for beta,
340, sir.
okay, thank you, 340. And then for gamma,
300.
300.
300, okay. So we have the contribution margins. Of course, you can do it differently. For me, it's good practice to separate the givens. Okay, the advantage of this is that if you change a particular value here, okay, if you change a particular value, then if this is linked to your model, you can just change the value that will change, and then the model will follow. Okay, so the objective function is maximizing your contribution margin. So we write here contribution margin, okay, per product. No? So contribution margin of products. Okay, and then I link this with is equal to this one, is equal to this, and is equal to this. Okay, the advantage of this one is that if, for example, if this contribution margin is to be used in other portions of this model. And then if there's a change in the contribution margin, you will just have to change one place here. And then automatically the others will also follow. Okay. All right. And what will be our objective function? What will be our objective function? We know that it's the contribution margin of alpha times alpha, contribution of margin of beta times beta, contribution of margin of gamma times gamma, right? So it will be 350 times whatever alpha is, 340 times whatever gamma beta is, and 300 times whatever gamma is. Okay, so we can put that here, just put it here. Okay, and then I'll put it in thick box so that, and maybe light brown here, so that we can easily see. Okay, we can easily see that this is the, and maybe put in red icon, red font, so that we know that this is the objective function. Because especially if you're working with a quite a big model, okay, and it might be difficult to find where your objective function is. So the color coding comes in very handy. All right. So what will be my formula here? Okay. By the way, a while ago I mentioned something about named ranges. I think it's about time that I introduce that. Okay, what are named ranges? It's also a powerful tool in modeling. Each cell in Excel has a name. Okay, nawawala yung ano ko, yung formula bar at saka ano nangyari dun? Why is it not showing? Tapos ando dun dapat yung name box. What happened to my... Did Excel deliberately change the... Okay, wait. So where is the formula bar? Tapos dapat I should see the name box here.
Sir, in the view,
Sa
on the
view.
view function,
Okay. Ano
formula bar, sir.
Sorry. Kaya pala kasi kanina, kanina I was na click yun. I was hiding the grid lines, no? So a while ago, so nasama ko yung so let me go back there. Thank you. So view, and then ayun, I accidentally pressed unclick the formula bar. Yun. Okay, that's good. All right, thank you. Na-miss na accidentally na click. Okay, so this is the name box, no? This is the name box. Each cell here in Excel has a name. Yung column at saka yung row. So this is F4. This has a name B2. This has a name B3. This is a name B4. Now sometimes it might be better to give these special names. For example, I want to give this a name, this 350, I want to call it CM alpha. And so I purposely placed the name beside the value. Okay, so how do I give this a name? This 350, I want it to be called CM alpha. And there are reasons why we would want to give names to cells. Because number one, when you're modeling and when we use that name, it makes more sense. Kasi kunyari, instead of B2 times this one, ang lalabas sa formula natin, C contribution margin alpha times whatever. No? So there are different ways to give names to cells. So pwedeng individually, you go to this cell and you'd like to give it a name CM alpha. So you type CM alpha here and then enter. So this one will now be called not B2, but CM alpha. Okay, so that's giving names to cells. If we have many cells that we would like to give names to, it's best to put them together, okay, beside each other. For example, this one, I'm giving CM alpha the name to this 350, CM beta to 340, and this one to 300. Okay, so how do we do it? We can highlight this, okay, highlight this, and then, okay, I pressed something here. It tells us create names from the values in the left column. So Excel correctly guesses that the names are in the left column. Okay. So what? Who's using? Anybody using Mac there? Who's using Mac? Okay, si Jason. Who else? Si Robbie. So only two, no? Good. Most of you are using Windows, so that's good. But for Jason and Robbie, you have to help me because I'm using Windows, so I might not. I'm not using Mac anymore. Matagal na ako hindi nakakagamit ng Mac, kaya hindi ko nakakabisado, no? So, all right. So for the Windows users, what you do is you highlight this, and Mac users also highlight it, and then I'm pressing Command Shift F3. Okay, so it depends also on your keyboard, but try to see first Command Shift F3. For Mac, maybe Command Function F3. Could you kindly check if that's the command, so that it will generate this create names from selection. And when you have that, please kindly chat yes. If you were able to generate this Command Shift F3, so create names from values in the left column. Okay, thank you, Clary. Sa Mac, Control Shift F3 ba? Okay. Sa Mac daw, Control Shift F3. Sa Windows, correct. Sa Mac, Command, ano ba? Robbie, ano sa inyo? Command Function, Command Option, baka Command Option F3. Not yet working. Try Command Option F3. So Charlie, are you referring to Mac?
I think ang kapalit po yata ng control sa Mac is command.
Pero yung shift hindi ko lang sigurado kasi
pero same lang po. Control
okay.
Tapos yung shift. Ganun.
Try nyo nga Robbie, Command Shift F3.
Yes.
And how about the rest, please? Could you kindly comment if you got this dialog box? I have the feedback of the others if they were able to get this dialog box by pressing Control Shift F3. Okay, thank you. Mac users, Jason and Robbie. Okay, thank you. Not working. Jason, how about sa Mac mo? Okay. Walang F3? Meron F3 yan. Wala bang F3 ang Mac? Mac keyboard? I know meron. Oh, really? F2 and then F4 na agad? Joke lang pala. Nagjo-joke yata, Erwin. Oh, meron F3. Pero, try nyo Command shift function F3. Tayo nyo nga, kasi baka F3 nyo kailangan yung you might need to press function. Kasi may mga ganong keyboard na you need to press function. Or Alt, no? Or kung hindi talaga makuha, anyway, you can just do it manually na muna and then hanapin na lang sa, i-google nyo na lang yung how to create names from selection. Yung shortcut on how to create names from selection. Okay, Jason, Robbie, huh? Okay, you can do it manually first. So let me show you how to do it manually. Okay, so you go here, and then dito sa name box type CM_alpha. Hindi pa pwede yung name na may space, no? Either you connect CM alpha or you say CM_alpha. Okay, and then do that for beta and do that for gamma. Isa-isa nga lang, yun ang disadvantage nun. Unlike if you can do this together, Control Shift F3, okay, and then Excel guesses that the names are in the left columns, okay. All right, so now if I go here, notice that the name of this cell is not B2 but CM. If I click this name box, yan, CM beta, CM gamma. Ano advantage yan? Well, you can, if I go to another worksheet, here for example, and I need that value, okay, I don't need to type is equal to, and then I go to that cell, no? Para hanapin yun. I can just access the names and CM. Okay, tingnan nyo, no? If I type CM, lalabas na to. CM alpha, CM beta, CM gamma. Okay? So CM alpha, tab, and I get that value, 350. Okay? And that is CM alpha, because that's the shortcut that we gave. That's the name that we gave, not shortcut, the name that we gave to this particular cell. And this particular cell has a name, CM alpha. And for the whole worksheet, for the whole workbook, the CM alpha refers to this 350. Pwede rin, no? Ito yung shortcut kasi. Yung sinasabi ni Cole, you go to formulas, okay? And then create names from selection, ito yun. But I'm particularly biased to the use of mouse. So kung pwedeng keyboard shortcut lang, highlight lang to, and then Control Shift F3, diba? Yun. Kasi pag create names from selection pa, okay, so highlight them, and then go to formulas, go to create names from selection, go to this one. Mas mahabang steps, no? Unlike kapag keyboard shortcuts, mas mabilis siya. Okay, ang sabi ni ano dito, pwede rin i-highlight yung cells. Okay, and then type dun sa name box. Yes, that was what we were mentioning a while ago. Okay, so this one, kasi ito, diba, nakalink naman dyan, so okay lang yan, no? Or you can type here CM, CM alpha, okay, which will automatically link there. Okay, and then this one is equal to CM beta, and then this one is CM gamma. Okay, so that's just a side point here. So while we are doing Excel, I'd like to share with you some techniques or tips which will enhance your functionality, your speed in using Excel. Okay, so this one, we need to get the total contribution margin, right? So we can name this as total CM. Okay, you can put it here or put it there for as long as it's beside it, so that we know that this cell, particular cell, is your total contribution margin. So what's the formula for this, class? What will be our formula for this one? How do we compute for the total contribution margin? Could anyone share or unmute yourself? What do you suggest? Our total contribution margin is the contribution margin, right, times the unit. So what will this be? And sometimes I would color code this to set it aside from the model itself. Okay, this is for me, this is one of the best technique that you can use, especially when you're dealing with constants. Okay, and then you just refer to this, especially if you're using that metric that measure many times in your model. This is a very efficient way to do it. So that if one changes, you can just change it here, and automatically it will change throughout the whole model. Okay, class, about this? Any suggestion?
Sir,
Yes.
the formula will be CM alpha times number of pounds
Okay,
plus
so it will be
CM.
equal to this
Uh,
one.
yes, sir. CM alpha times number of
Okay,
pounds
CM times
for alpha.
number of pounds
So
is one.
B10. Yes, sir.
Okay,
Plus
plus
CM beta
this one.
times.
Or
Yes, sir.
we could have used we could have used CM beta, right?
CM beta. Yes, sir.
Okay, we can use that
Times
times beta.
the beta.
Okay,
And then plus CM gamma times number of pounds.
okay, times gamma. Okay. All right. So it's 0 now. Let's make this carry 2 decimal places. All right. Why is it 0 now? Why don't we have a contribution margin yet?
Because number of pounds is blank.
Exactly. We don't have any answer yet for the decision variables. We don't have the units for the decision variables. Okay. All right. So this now we now have your decision variables. We now also have our objective function. So that leaves us with our constraints. Okay. So for the constraints, we can make use of this table. Okay. We can make use of this table. Let's attach the table here. Okay. Okay. What do you suggest, class? What do you suggest? Any suggestion? So this is part of modeling, thinking of how we can rearrange our data so that it fits our purpose. Okay. So Jason. Okay. Sabi ni Jason dito, sa M1 Pro onwards ng Mac, wala nang function keys pero long cut will work. Okay. Sige. Okay. Thank you, Jason. Okay. Right. Yun ang isang ano ng Mac, no? All right. Now yung ano natin, class, yung constraints. Okay, sana makahabol tayo ng 4:30. Let's try to finish at least this problem. At least makita na natin yung solution, no? If you take a look at our constraint, ito siya, no? You have your left-hand side and your right-hand side. Okay, so the challenge is how do we arrange this in such a way that it will fit our model. Okay, kasi andito na yung ano, andito yung alpha, no? So how do we arrange this in such a way that lalabas yung left-hand side natin at saka yung right-hand side natin.
Pwede po nating i-divide by 16 yung chemical, yung ano po, value para pareho or
Yung-
times 16 value.
So babalik tayo dun sa ano, gagawin nating ano,
Hindi pa
gagawin
siya
natin.
pantay.
So, pag hindi pantay, ipantay natin. So, ano bang maganda dito? Kasi andi dito si alpha, di ba? Right. If I put this here, okay, kasi, sorry let me fix the dog first. Okay, so we need 4 times alpha, no? And then what? What class? Ito yung equation. Take a look at the equation. So we need 4 times alpha, okay, plus 3 times beta, plus 6 times gamma. We need the constraint for chemical A. Transpose, kailangan ba natin i-transpose? Okay. Do we need to transpose this, Erwin?
I think, sir, para maging kamukha niya yung sa equation natin kanina.
Okay. So, okay, sige. I'll do that, ha. Ita-transpose ko to. Control C. And then, paste special ito, no? Ito. Transpose. Okay, ito yung sinasabi ni Erwin, no? Naka-transpose siya. Pag nakaganyan ngayon, how do we go about this? Ito, naka-transpose na to.
Yes, sir. No. Parang similar formula dun sa CM. Bali, number of alpha in terms of in pounds times 4
Okay.
plus number of beta times 3
Okay.
plus number of gamma times 6 is equal to yung total ounces ng
Okay.
no chemical A. Yes.
Iliitan ko, ha. So it will be, ang sinasuggest ni Erwin, this way, no? Kasi 4 times alpha plus 3 times beta plus 6 times gamma. Right?
Yes, sir.
Tama ba?
Yes.
Class, what do you think? Comment from the class? Okay, once again, take a look at, now this is very critical, this is very important because this will help you in deciding how you're going to model. Kasi, di ba, ito yung ano natin, no? Ito yung constraint natin for chemical A. Now, for the constraints, we have to have one cell for your left-hand side and another cell for your right-hand side. So that's what we have to remember. Dapat yung left-hand side should be one cell and the right-hand side should be another cell. Okay, ito yung sabi ni Chari, ano? Okay. Okay, ang suggestion ni Chari, alpha, beta, gamma, and then chem A, chem B, chem C. Okay. So, same as ano sinabi ni Erwin, no? Sabi ni Erwin, i-transpose natin. Okay? So here, this is now the transpose table, no? So let me also transpose this. Dapat sinama ko na tong ano. Let me repeat this. Okay? Control, copy natin. So to transpose, class, copy lang siya. Control C. Okay. Highlight natin table natin, Control C, and then put it where you want to put it. Right click, and then this one, no? It's in transpose. Okay, and then dapat dito. Okay, take a look at our table now. So we now have this chem A. Notice, ito na yung mga ano ni chem A. 4 3, and 6. Okay? Tapos, andito si alpha. Alpha, beta, and gamma. So we can now do this multiplication. 4 times alpha plus 3 times beta plus 6 times gamma. Right? Tama ba, class? Because that's the left-hand side. 4 times alpha plus 3 times beta plus 6 times gamma. Di ba? All right. So let me remove this. Kasi ang kailangan, ang mas ang natin na format ito. Let me delete this. Okay, thank you, Chari. May space dito. All right. Now, what will be our formula? Sabi natin, kailangan may left-hand side, di ba? May left-hand side at saka may right-hand side. So what will be the left-hand side? What will be my equation here? Let me go back to the constraint. So the constraint is 4 times alpha plus 3 times beta plus 6 times gamma. That will be the equation for Chem A. So it's important for us to create a model in such a way that madali din yung magpo-formula tayo. Madali din yung, it will be easy for us to generate our left-hand side and right-hand side, for example. So this one, had we not transposed it, okay, as suggested by Erwin, which is correct, it would be very difficult for us to formulate your left-hand side. Here, in this case, it will be easy. Why? What will be my formula? We have now alpha, beta here, okay, and these are the coefficients of Chem A. So it's just a matter of just like getting the product of the sum for contribution margin, right? So it will be 4 times this one plus 3 times this one plus 6 times this one. Okay. All right. So what should be my formula here, class? It will be equal to class. Okay. So in the interest of time, so instead of using this 4 times alpha, right, plus 3 times beta, okay, plus 6 times gamma. Okay lang siya, no? Okay lang siya kasi konti lang naman. But in case we have many coefficients, okay, it will be very unwieldy. So we can make use of a functionality in Excel called the sum product. No? I don't know if you have used this, but the sum product returns the sum of the products of corresponding ranges of or arrays. So you first get the product and then get the sum. So it's the sum of the products. So ang syntax niya, ano yung array 1 natin? So yung array 1 natin, yung coefficient natin ng chemical, and then comma, yung alpha, beta, gamma natin. All right? Now, how are we going to copy the formula? We're going to copy the formula going down, right? If I don't do anything with that formula, magkakamali tayo. No? Control Enter. And then if I drag it down, okay, may answer dito, which should not be the case. Kasi what happened was, yung alpha beta natin, it moved down also. All right? So how should we address this so that isang formula lang tayo, copy down, tama tayo. So it should be the sum product of this array and this one, yung B8 to T8, and then we have to fix this. Okay? So how do you fix the cell? F4. F4. So ano yung tama dito? Yung F4, ito, ibig sabihin nito, B8, B8, walang i-fix dito. Dito naman, $B, $8, $D, $8. Nakafix si B, nakafix si 8, nakafix si D, nakafix si 8. Dito, ang nakafix lang, Kung sino yung sinusundan, whatever is followed by the $sign, that's fixed. And this one, column B is fixed. So which is the correct address here? This one, class. If I fix this one, B8, D8, both the column and the row will be fixed. So if I go down, okay, let's see. If I copy it down. All right. So what happened here? So it still remains here, right? If I go here, it still remained here. If I go here, it still remained at B8 to D8. So B8, D8 is correct. Okay? B8, D8 is correct. All right. However, there's such a thing as parsimonious model in Excel, but I'll discuss that next time na lang. Okay, so you don't need actually to fix both the rows and the columns. What you need to fix is only, as mentioned by Erwin, pwede na yung row. Bakit? Kasi ang question dito, how are we going to copy the formula? We're going to copy the formula down. Now, it will remain in column E, no? Yung formula natin na i-copy, we're going to copy it going down. So the column position is not changing. So there's no point in fixing B and D. Diba? Kasi yung pag-copy natin ng formula pababa and column E is not changing. So why do you have to fix the columns? Kasi yung columns naman hindi nag-change. So, okay. This pwede na to. B $8 and D $8. We only fix the row. Okay, and not necessarily the column. So Control Enter, and then we move down. All right. So let's see. So it's the sum product. So it's 4 times alpha, 3 times beta, and 6 times gamma. It's a sum product of this row and this row. And then if we go down here, it's also the sum product of this chemical B and the decision variables, etc. hanggang base. Okay? All right. Permission, guys, to just finish this solution. Kasi 4:30 na. Pero mabibitin tayo nito pag pag hindi natin Okay lang?
Sige po.
Sige. Thank you. All right. So we now have our left-hand side. And again, for better monitoring, pwede natin left-hand side, pwede natin gawing ganitong color na lang, no? But not red. So we know that this is the left-hand side. And then, so this is the LHS. I'll just put here left-hand side ng constraints natin. Oops. And then, you can put the operator if you want, less than or equal to, for clarity. Okay, less than or equal to. And then we have here, okay, okay. Let's just give the final value here. Ano yung mga final values dito?
8,000, sir.
8,000.
6,800.
6,800.
10,400.
10,400.
And 17,600.
17,600. Of course, class, there's a better way to do this, no? Dapat meron din tayong cells dito ng chemical A, inventory nila, and then we can do the manipulation here. But for now, just to get the final answer, we'll put this here. All right, and then we'll label this. We'll just continue with this next meeting, but I just want to show the final answer. Okay, so what other constraints do we have? What other constraint? The minimum demand, right? The minimum demand for alpha, beta, and gamma. Okay, so how do we do that? Maybe we can just insert here, and then I'll just put here minimum demand. For the minimum demand, we already have, okay, here, we already have the left-hand side. Okay, take a look at this. We already have the left-hand side. This is the left-hand side, diba? Alpha, beta, and gamma. Ito yan. We have this already. Okay, so which means that we don't need to provide a left-hand side for the minimum demand. But what we need to provide is the right-hand side. So let's put here minimum demand. And this is ilan to? 1,000 ba to? 1,000 and then
1,500 and then
500
400.
and then 400. Okay. All right. Let that be now. We'll just improve on this next time. I just want us to know how to use Solver. All right. So let's go to Solver now. Okay. Let's first check. So go here, File. Okay. Options. File Options. And then here, kindly take a look. File Options and then Add-ins. Okay. File Options, Add-ins. And then here, you will see below Excel add-ins. Okay. Okay, again, File. Let me redo that. File, and then Options. All right. Hindi na pala kailangan na add-ins. Meron na ditong diretso. Hindi, kailangan pa rin. Add-ins. File Options, Add-ins. Here. And then this will appear. Excel add-ins, and then go. Okay. And then here you have Analysis Toolpack, Eurocurrency, VBA Analysis Toolpack, and then Solver add-in. So we click this Solver add-in and then OK. Right? Are you following, class?
Yes,
Yes,
sir.
sir.
Okay, good. Good. So once you have the Solver add-ins, okay, where do we go? So you go to data, and then data, and then you will see here analyze. Solver. That's what we added in. Solver add-in. Data, solver. Okay. And then you have this dialog box. You have three main parts here. This one, and this one. These are the three parts of your linear model. Set objective, this is your objective function. By changing cells, this is your decision variables. And this one, these are your constraints. Okay? Just a minute, guys. Sandali, ah. Okay, sorry, there was a knock on the door. All right, so objective natin, where's our objective? Ito, di ba? We would like to maximize this. So you go here, all right, click this. Set objective, this one. All right, so it's maximize, minimize, value of, it's maximization, so that's the default. Okay, yan. All right, then by changing cells, that's why, see, it's important for us to color code it so that we can easily see. Okay, changing cells, these are the light blue ones there. Okay. And then you have the constraints. Okay. Now there's next meeting we're going to discuss more how constraints should be positioned, but take a look at this subject to the constraints. So we add here, add. Okay, what happened? What's happening? Hindi nagpakita ito. All right. So if you notice this class, this is your left-hand side, this is your relationship, and this is your right-hand side. Diba? Okay, it's best to really fix your model in such a way that for cell references, for the chemicals, for the inventory, these are your left-hand sides. Okay, highlight them together. And then it's either less than or equal to, greater than, equal to. Notice that there are no greater than or less than. So it's either integer, binary, or all different. So it's less than or equal to, which is the default. And the right-hand side is this one. So this is the right-hand side. Okay. So are there other constraints? Yes. So let's add here. So how about the constraints for the minimum demand? So your cell reference, your left-hand side, are your alpha, beta, and gamma, right? And then your minimum demand should be greater than or equal to, you have this, greater than or equal to 1,500 and 400. Okay. Are there any other constraints? Okay. If there was a non-negativity constraint, you can just, sorry, ano nangyari dun? Should be here. If there are non-negativity constraints, you should, you can now, add this, and then this cells, and then, okay, it can be greater than or equal to 0. Okay, but there's an easier way actually here, this one. So this is the default. Make unconstrained variables non-negative, which means that this is non-negativity. All right. And lastly, I'm sorry for standing a bit. The method for usually for a simple linear programming model, we use the simplex algorithm here. GRG is for nonlinear. Evolutionary is for also type of nonlinear. So simplex there. All right. Okay. And then let's solve. We'll discuss this again next time. Solve. And there we have solver found a solution. All constraints and optimality conditions are satisfied. Okay. There. So we now have a solution where we're going to produce 1,000 pounds of alpha, 533.33 pounds of beta, 400 pounds of gamma. The total contribution margin is 651,333. And if we check the constraints, here, chemical A was used up, di ba? 8,000 na gamit sa kanya. Si chemical B, may natira pa, may slack pa to, no? Si chemical C, may slack pa. Si base, may slack pa rin. Okay? So next meeting, we're going to go through this again. I'll just go through the nitty-gritty details. Okay, so at least you have learned today how to navigate through Solver. I'm going to post the video in our Canvas. Okay, class, are there any questions? Sorry for the extension. Any questions? Let me stop.
None, sir. Thank you, sir.